Good
Morning.
morning. Good
How are
morning.
you doing?
Can you guys hear me okay?
Very good.
That's wonderful. That's
Nice and
wonderful.
nice and clear. So tell us where you're calling in from.
So I'm coming from Connecticut on the East Coast of the United States. So we're about 2 hours from New York, about an hour and a half from Boston. I guess I should probably open up, I guess because it's an American thing with dogs. So this is my dog. His name's Eric, and he kind of is my partner in crime sometimes here. So welcome and thank you.
Thank you.
So
I'm going to hand right over to you and get off the screen.
great, thank you. So yeah, I guess who am I? I'm very happy to be here and talking to you guys today. I don't necessarily have anything that I'm pitching, so apologize for that in advance. But my name is Constantine Macris. I'm an instructor of cyber systems at the United States Coast Guard Academy. I do incident response and forensics. I'm also a student at the Naval War College and Navy reservist. I am, I guess, a self-proclaimed security innovator, but I spend most of my mornings teaching. I teach a course called Computer Network Securities that I developed at the Coast Guard Academy. Spend most days researching maritime industrial controls, so kind of Mackenzie or mechanized. Was actually one of the instructors in a class, SANS class I just took. So it was very good to see him again. And again, you have a great knowledge base there at Savannah River. So again, we're kind of doing something very similar at the Coast Guard Academy, more maritime centric. And that's what I'm going to be talking about today around this frame of digital feudalism. So probably have to explain what that is. I spend most of my nights, however, working on one of a million different projects. I often will respond to an incident, depending on what's going on. And again, taking those classes at the Naval War College, I keep pretty busy. So I just wanted to thank for a moment to to reinforce the folks at Dispel had actually made this presentation possible, and the NZDIA. Thank you guys very much for agreeing to give me 30 minutes to talk. I think my students probably would have advised otherwise, not having more bounded ends on this. So you guys can feel free to look me up on LinkedIn. There's not too many Constantine Macrises, and at the end of the presentation, I'll have the link to this material as well as kind of like the show notes associated with kind of what I'm going off of. My security journey started in 2002. I was a student at the United States Merchant Marine Academy, and I joined the network security team there, which is a competition team that essentially takes part in capture the flag competitions and cyber-related competitions. It was still in its infancy at that point. I think it was the first or second year that they had it when I was a freshman. So I had to learn a little bit about network security, and I learned that security is in fact a human problem, right? It's a human problem. With lots of computers, lots of technology, lots of line of code, and those lines of code actually made the problem, but we're going to use lots of lines of code to actually solve the problem as well. So it's a lot more complicated kind of than it is on the surface, especially as you start getting into the actual technology that makes security secure or insecure. And that's kind of what I'm going to be talking about today. I learned a lot while I was on the cyber team. I learned how to order pizza and make coffee for the team. By my first class year, which is senior year, I had gotten pretty good at making coffee, even better at ordering pizza. But I got kind of cemented in the leadership position of actually moving machines from one spot to another. So I was definitely not a top performer there, but I really liked it. So after graduation, I sailed commercially on my Coast Guard license for about 8 years. The ship would park at docks at night, usually, depending on the nights. And I would essentially have the plant was shut down. I was able to kind of learn the systems. Through learning the systems, I realized that all of that coffee making and pizza ordering actually kind of prepared me to learn a lot about how to control these systems in ways they weren't designed to. So I was moving the rudder, with a laptop, and essentially I was using a bunch of microcontrollers, some radios to, to essentially reverse how a lot of these systems worked. So kind of put that in my pocket. I was a commercial engineer, operating engineer, took my assortment of radios and microcontrollers to other purposes. I deployed to Africa with the Navy for a year. And after that, I worked with a nonprofit developing remote sensing and reporting shipboard devices for environmental service vessels. That led me to ultimately managing and rebuilding a large defense contractor's classified information system, learned a lot about the NIST control set there and the actual application of technology in a government information system. NIST is the National Institute of Standards and Technology here in the United States, and they have a great control set that we can talk about a little bit later. This led to similar work like that with the Navy, consulting, followed that, and finally I ended up at the Coast Guard Academy. I'm an instructor there, so I'm pretty much bottom of the barrel, not a professor, just an instructor, but I love it there and have a great time where I actually get to continue to make coffee and figure out how to take over control systems of ships and various other widgets. Sounds like a lot like Savannah River too, only with a maritime theme, which is kind of the lens we're taking for this. I have the same microcontrollers, radios, so on and so forth. So right now, with joking aside, I want to talk about kind of this concept of digital feudalism and kind of what that means from a government perspective, right? First off, what it is, and second off, like kind of how do we solve this problem of living under kind of a, what they call digital feudal lord? Well, I'll talk a little bit about my perspective on building secure environments, maritime industry and IT networks, and then kind of this idea of future-proofing things and kind of separating ourselves from the digital feudal lords, and then kind of some of the tools that can that I've identified to make this happen. I really want, and we can take a takeaway slide. I really want people to kind of take away that we can rethink our relationship with technology. And I think that's very important. And then kind of think about how we're actually utilizing, where we are right now, how are we utilizing technology to gain capabilities and efficiencies? Because that's why we have these tools in the first place, is to kind of gain some sort of efficiency or capability. So I want to start with my grandfather's car. My grandfather had a Chrysler 300. That's the beautiful red car at the top left. And my father had a Chrysler 300 from 2012, let's say, or 15 or whatever. So same model car, right? My grandfather was an engineer from a Big Ten school in the United States, which is, a pretty competitive engineering school. My father, same way. And my grandfather knew everything about that car, right? Everything about how the headlights work, to how the internal combustion engine worked, to the oiling system. He could design it, right? He was an engineer. Like, that's what they did. And my father had the same car, same model, same kind of like level. It's not like, one person had a bicycle and the other person had a jet, same thing, right? Same piece of technology we're using, same function. And my father couldn't tell you how the headlight worked. Couldn't tell you how the headlight, not because he didn't know how lights worked, not because he didn't understand switches. It's because we went from one signal on one wire to multiple signals on one wire. And it went from being able to connect something that we had readily available, like a light bulb, to see if something's working, like a light bulb and a relay, right? You can figure out kind of, old car. To now we need a logic analyzer, we need oscilloscope, we need like some more tools. And it got lost to him, right? And it got lost to a lot of people. And that's really the core of what we're talking about. I had a light bulb here, actually. We can think of a light bulb, right? An incandescent light bulb, everyone kind of gets an idea that works, right? We know, there's a filament, the filament gets hot, it glows red, we can feel it, we can see it, right? We turn it off, we turn it on, right? When we went to fluorescent bulbs, it changed a little bit, right? We had a gas, we had to excite the gas, it had some phosphor in it that then, allowed us to see the non-visible spectrum, right? Some people still followed, right? We had a ballast, we had a starter, we had ballastless starters, and then we went to LEDs, right? That's this thing here that's reflecting off my glasses that I apologize about. And we lost more people, right? And then we went to, I have a box of smart bulbs over here. We got smart bulbs, so now they connect to the internet, right? So we've gone from something that we utilize every day and we understand how it works to something we utilize every day and we don't understand how it works. They say the iPad, my 2-year-old can use it. It's like, oh, should we be proud of that, right? But that's kind of where I moved to digital feudalism. And it's this idea, and it was actually coined in 2013 in the Multi-Stakeholder Internet Dialogue, which is a publication which I think has since stopped. But in my notes, you'll have the link to that. And Bruce Schneier is a leading cryptographer in the United States and wrote multiple books that you probably have heard of. One of them, the most well-known, being a text called Applied Cryptography. So in 2013, he pretty much warned that the world was going towards this age of digital feudalism. So what does that mean? And he described it as there would have to be, for normal people, the ability to align yourself with a digital feudal lord, right? Those digital feudal lords would, take something in exchange for providing you protection in a dangerous and, complicated digital world. And the underpinnings also then go into how government lags all of this technology, right? So the feudal lords and government are kind of two separate things, and then you have fringe organizations, criminals, dissidents, freedom fighters, he pointed out, and they're able to live outside of this system because they have the skills to be able to do so. So that brings about, I work for the United States government. I'm a reservist in the Navy of the United States. So I'm kind of a G-man in that I work for, I'm the government side of this. And I'm like, this is a problem. I've worked with these information systems. I see how slow it is. And I understand that there's a lot that goes into it. But I think the core, and this is kind of, what I'm presenting, is that we don't have this intimate relationship with the technology that we use every day. And because of that, it's become unattainable. Now, for instance, I have, my phone. I've actually signed up under the feudal lord of Google, and Google has provided me storage of my most cherished photos of my family. All they'll do is just, essentially categorize them, scan them, get, my children's face catalog for their entire growth. They'll provide me with email, but you know what? They're going to read every one of my emails. They're going to provide me, advertisements for that. They provide me the knowledge of the world in my pocket. But every time I search something, it gets added to an account so that they'll have a better understanding of how I think. So I am using the protection of Google for those services, right? And I think that it's important to realize that we are, to some extent, all under the control of some digital feudal lord. Now, what does that mean for the government, right? And how can we adopt technologies to more rapidly keep up with not only the feudal lords, but also the criminals and the adversaries that are on the front line of this? This is difficult. And this is the problem that I'm working on solving, in a couple ways. One, through education, and the other through independent research. So with that being said, I kind of want to put this in the frame of maritime. So 80% of global trade travels by ship. GDP of the world is set to increase, and with that, shipping is going to, essentially follow it in a linear fashion, right? A.T. Mahan, and this is, going back to war college days, in The Influence of Sea Power Upon History, 1660 to 1730, kind of described why we need sea power, why do we need navies, right? And it's to protect commerce. It's to essentially to ensure that mercantile nations have the ability to keep sea lines of communication open, right? So, with the fact that commercial shipping is, essentially necessary for, a secure, functioning economy, and the Navy's job is to essentially protect shipping. And now, instead of, playing in the Middle East as much, we're going to be looking towards, great power conflict, and, understanding that we're looking back to protecting these sort of things. It really brings a focus as to, in these maritime systems, how do we actually kind of do what Savannah River was talking about? And for that matter, Sean, and I think he was with Palo Alto, was talking about zero trust. Imagine those things kind of wrapped up in everything that we're talking about right now, right? And wrapped at a level, and I'm proposing that we get to a level where we're understanding the technology that we're using, or having a relationship with the technology that we're using beyond what we're actually doing right now. So for those without a maritime background, ships are very much like power plants that move around. A lot of the issues that Mackenzie talked about with remote access are constant on ships. Like, we have to be able to manage industrial control systems from anywhere in the world, right? There's systems that control the rudder. There's systems that control the ballast. There's systems that control generation. So all of these things work in concert to create a ship, whether it's commercial or military, that can operate at the level that it needs to. The only difference is that you don't have this static IT team that's there for the information technology, and you don't have this static OT team that's there managing. You have operators. And when I was at the United States Merchant Marine Academy, the education that we got was more on how steam engines worked, more on how diesel engines worked, how to run a generator, right? We knew the word industrial control, but we didn't actually have them and get to play with them. So OT networks were always looked at kind of as these static things, right? Like something we buy, like a toaster oven, right? And it makes toast for us, right? Like we put it in, makes toast, take the toast out. And that's all it did. Now we've got these toasters that are connected to the internet, these light bulbs that are connected to the internet, and they can do things that are unintended. They could be parts of a botnet. They could be an ingress point to your network. And we very often will implement features without actually understanding the full ramifications of that. And that really comes down to risk. And when I'm labbing something up and I'm showing some sort of vulnerability, a lot of people that I'll have to tie down to a chair to watch me do something will say, yeah, that's great, Constantine, but you need to be there and do this and do that and all these hoops I have to jump through. And I say, yeah, but I agree. It may be a very low likelihood, but the issue is it's a very, very high impact. It's a very, very high effect, right? That could happen. So imagine I worked in New York City and I worked on tankers, and it was a 360-foot tanker. And we would tool around New York City Harbor at about 14 knots. And we would go under bridges and up bridges and through Hell's Gate and docked. And, the night before I had been sitting in the engine room and using my cell phone to move the rudder, right? Based on something I was working on. And, I was just thinking, how bad would that be if an attacker was doing this and all of a sudden the ship went into the Brooklyn Bridge? That'd be catastrophic, right? What if we took a container ship and in the Thimble Shoals outside of Norfolk in the United States, where the Atlantic Fleet is based out of, and we put a ship over on its side like that, right? What sort of effect would that have? What about Thimble Shoals right there? What about if we have collisions with ships at inopportune times, battleships, warships? I mean, the like. So the point being is that these are very high impact items. So no matter how unlikely the effect may be to happen, the impact of it, the impact level is so catastrophic and so high that it cannot be ignored. So what does this mean with maritime? Well, the bridge system on a lot of ships, and the Coast Guard is adopting this, is consumer off-the-shelf technology, right? So COTS. And COTS bridge systems are really based on standards, and Mackenzie mentioned a number of them, Profibus, Modbus, right? And a lot of them are unauthenticated. So NEMA 2000 is the one that a lot of navigation controls work off of, and they work off of NEMA 2000 and AIS being the radio transmission. And we've patched it up a little bit, right? Like we can encrypt at the application layer, send it over AIS and decrypt, and it works. The issue being is that we're really not training on these sorts of things, right? And that's really where my focus comes in, is changing the relationship that we have from being a general user, someone that can just operate. Like, if you can use your phone, right? You're a general user. You and my 2-year-old can, talk about how you can move icons around and click on the button to chat with grandma, right? But what I've found is that we don't have the tools and the confidence really to allow people, normal people, and I'm not talking, people that this is all they do. I'm talking about people, operators, right? To be able to fiddle at the level where they get a, internal understanding of this. So what I'm really working on is fostering the next generation's understanding of technology. So to do that, we involve hardware hacking, right? So this involves students being able to pull communications off of a wire, decipher novel protocols, go back to essentially bit by bit, trying to figure out what's going on, bit banging, and writing software to do that, using all of the tools at their disposal to do such a thing. What I'm trying to also do is allow them to have, as Mackenzie was describing, a lot of this stuff is really expensive, right? Like if you want to build an ICS lab at home, right, a maritime one, I think $5,000 gets you started with like a NEMA 2000 head unit, for GPS and navigation. So, we need to essentially teach to do these sort of things with open standards and tooling that is easily attainable. Using open source, open standards, switches, routers that are easy to get images from, where you don't need to essentially sign up for some expensive program to be able to get your image, use a router that's open source available, that sort of thing, so that as people get problems, we're giving them the tools to be able to lab them up and try them, to have a better relationship, a more intimate relationship with technology, to keep us not under necessarily the feudal lord, but essentially allow us the independence to be able to do those sorts of things. We're also pushing forward on the technology that we're using. Things like adopting Ansible, Terraform, on-prem, cloud, essentially solve problems with the tools that are available. It just happens those tools are also open source, but essentially providing them the ability to use those tools. I've got about 4 minutes left. So that's what I'm doing at the Academy. We're building labs. We're building a maritime simulator actually with, CISA, which is the cybersecurity infrastructure agency here, and I'm sure that Savannah River also works with them. And Idaho National Labs is involved. They're doing most of those platforms, but we're mocking up the maritime platforms to see how that would actually look, to add kind of that maritime component into these critical systems. So my research is centered around building systems that build systems. So using a lot of those similar technologies, I want to be able to, every time we go on mission, to build a new system with an accreditation pack, so we can just say, let's go on the mission, stand alone, everything you need, if you're a ship, all the charts you need. If you're, somewhere where you can deploy to the back of a tank or Humvee or something, you have your data center, whatever it might be. It could be in a UAV, it could be in a tank. You don't care, right? You describe your environment and what's necessary in code. You deploy it. You can save the data after the mission's over. And then you essentially move that data to some sort of system of record where the risk is lower. And then you essentially tear it down and you rebuild it when you need it again. That's what we're doing now, right? Like I do that whenever I spin up labs. We instantiate an entire environment, networking, so on and so forth. You could do this on any hardware, really. You need a hypervisor, and depending on, there's depending on. But essentially, you're building the system, and you're also including the idea that we need to pull variables from this system: users, security controls, software hardware lists, right? Think the CIS V2 or V whatever it is, critical controls, the SANS critical top 20, or NIST 853, these kind of frameworks that require you to actually document what you have. So in the process of instantiating it, you already have your description of the system as code. So essentially pulling that down and making it a thing. So that's stuff that I've been researching to do today. And it just saves a lot of time so that we can keep up in this digital feudal race with the criminals, the adversaries, so that we can change and adapt as quickly as we go on mission, right? Next mission, we found that there's a new thing that we want to implement. We implement it. We put the accreditation pack together. Boom, they have a couple weeks, days, hours, whatever they need to approve it. We now have an approved accreditation pack. Information system's up. We go, we roll it, right? That's essentially where I'm at now, what I'm working on. And again, using the help of, I'm one person, so I don't have a lot of resources, but using the help of Ian there at Dispel and their project Pangolin is kind of the framework where I'm doing this. I'm working on this idea of really this evolving threat defense, where as you have an environment, let's say in the back of your Humvee, and you have an event that reaches a certain level, you would essentially mirror that environment, transfer over your services, and then see what happens. Save that data. So think of it as an artificial intelligence honeypot. That's really where I want to go with this, where we have the ability to iterate our systems, right? When I say evolving, every time you reinstantiate the environment to do whatever you want to do. And you can think of it from a web application. This is how we deploy. This is DevOps. This is how we deploy web applications. So the idea would be this is how we do business moving forward, right? We could start it with systems that don't need to live forever. Then we can start saying, okay, how are we going to do this so we can instantiate it when we need it? You know, I do this sort of stuff with continuing integration pipelines and such. So I think really that's what my mind is at right now. That's where I think that we're at. So again, that's how I'm trying to solve these problems. It's no one thing, right? It's nothing that you can really buy. What it is something, it's a mindset of changing how we have a relationship with technology and being able to always be pushing forward. So again, we need to realize where our reliances are, right? We need to keep in mind where we're gaining efficiency and capability through technology and use the best of it, right? And figure out how we can do that in a new, safe, secure manner so that we can get rid of all the old stuff and just make something new when we need something new. So I always say, you know, we need to be able to keep up with those fringe groups we were talking about. We must promote kind of this different relationship with technology where we're really asking, okay, how does this smart bulb work? I knew how a light bulb worked, but how does this work, right? And that's really, in the officers of the Coast Guard, the ones that are doing cyber systems, that's what I'm challenging them to do. Use not one piece of technology, not to be a technician, not to be a, you know, tactician, as it were, right? I want them to think more strategically about technology with the ability to dive in and understand every technical aspect. And that's where I think we're going to see the next level of fighting force come, and implementation of great tech. I mean, there's great technology out there. I've said open source a lot. There's great proprietary technology. What I really want to focus on is implementing everything as seamlessly as possible, and then also break stuff. So I think that the idea of having this relationship with technology is really you know, the core of where I think we need to be able to build the future of a secure and ever evolving and improving network system. So thank you guys very much. Again, my contact information is going to be in the handout. And if you go to nz.hacking.fans, you'll see kind of this horribly rendered HTML version of the talk. If you then go to the bottom of it, you'll see this link for a PDF handout, which will bring you to a nice, pretty PDF if you really care about the, you know, what was said here. And then the slides would be the same sort of thing, where you'll see the slides if for whatever reason you want those. But feel free to reach out to me to discuss. And again, thank you to everyone that's made this possible. And I think I'll leave a couple minutes for questions. I think you guys are running a little bit behind too, so be happy to take them offline. I don't know if I will stop sharing now.
So hi, Dean. Thank you so much. So first of all, I wanted to see whether your partner of crime was still paying attention.
What would that be? Oh,
Yeah,
Eric? Oh, he's not
Oh,
up here now. Are you kidding? He's 100 and some pounds. He snores and he'll snort and he'll go like run into the couch and knock stuff over. Yeah, no, I was like, this is kind of important. He's in the basement now, or he's downstairs with the kids.
Yep.
Yeah. I was like, Mackenzie? I don't know where Mackenzie is. He's in Georgia. I don't know where he is.
No, you know, so we had a cat video yesterday, so it was good to even the playing field with the dog, because I'm more of a dog person than a cat person. So a couple of things while I think about it. Could you change the name of your site from Hacking Fans to Packing? Because I think if anybody in NZDF put hacking into a search, there'll be somebody from the security team running down the corridor, hopefully.
Good for them.
Yes,
good. I can try to find a different. I don't know. I don't own the domain packing.fans, but I can do nz.macris.co.
Perfect.
How about that?
Perfect. No, that would
It'll
be good.
take me probably 20 minutes to do,
good.
though. So give me a little bit of time.
Good.
If you,
that's all good.
Sorry, that's just a domain that I use.
Yeah, no, that's good. So so there were a number of things you said which I think are important messages that we will push out when we curate the material. So all of the presentations are going to be curated, and I think some of those key reminders that were coming through. And I think the save needed data and then destroy it was another one for me. And then I think also they must promote a different relationship with technology. So I think we'll see those messages in our curation, and then also look at getting you to come back and talk to, you know, some more of our younger guys again in the future. So
I'll be happy to. Whatever you guys like. I love talking about this topic. I love digging deep technology all the way up to kind of strategic. So I kind of place myself in that operational level, and you know, kind of have found that there's lots of technical solutions and there's lots of strategic ideas, and connecting those two is kind of where I normally sit.
Awesome. So we're going to go to our break now. Are you going to head to the Dispel booth? Yeah,
sure.
That's an excellent idea. Then if anybody wants to come and chat to you, book you up for something. So if you go into the Expo stream tab on your screen, go look for Dispel, and I'll tell people that's where they'll find you.
Great. Thank you so much.
Thank you again, and thank you to Dispel for arranging to have you join us. And we're looking forward to having you engaging with our community again in the future.
Oh, yeah. However you guys like. Thank you so much.